Hey everybody, this is Mr. Beckstrom, and today we're going to be doing a hypothesis test using the critical value method on a claim made about a standard deviation. So this is the only one that we really have to do mainly by hand. This is number 8 on page 406 in our book. This will be similar also to the homework problem in my math lab. So let's go ahead and get right into this. This one says a simple random sample of birth weights of 30 girls has a standard deviation of 829.5 Hg. Use a 0.01 significance level to test the claim that birth weights of girls have the same standard deviation of birth weights of boys, which is 60.2 Hg. All right, so let's go ahead and start this just like we do any other hypothesis test. So first we want to state the claim in symbolic form. Remember that the notation that we use for standard deviation is the Greek letter sigma. Looks like this, lowercase sigma, so sigma, and it says the claim is that girls have the same, which is equal to that of boys, so is equal to, and boys is 60 or 660.2, so we're going to say that the standard deviation is equal to 660.2. So that is our claim in symbolic form, which means our null hypothesis of our standard deviation is always set equal to our claimed value, and our alternative hypothesis for a two-tailed test our standard deviation, it would be not equal to 660.2. Now with the standard deviation, I mean, we can normally do the p-value method or the critical value method, but since the calculators, the TI-83 and the TI-84, don't naturally do the p-values for the chi-square distribution, we're really only going to do the critical value method in this class. I believe you can do it with StatCrunch, but we're not using a lot of StatCrunch in this class, so I'd really just rather teach the critical value method for this one. All right, so the first thing that I want to do is I want to kind of set up our bell curve. Remember, the chi-square distribution is a right-skewed curve. It looks something like this. And this is a two-tailed test, like this. And so that means I'm going to have a critical value here, and I'm going to have a critical value here. So I need to identify those critical values. So that's going to be a chi-square left here, chi-square left, and I'll have a chi-square right value here, chi-square right. And once I identify these two values, then what I can do is I'm going to find our test statistic, which I wrote that here, and see where it goes. If it goes in the main body, I'm going to fail to reject our null hypothesis, and if it goes in either of those tails, then I will reject the null hypothesis. So let's first identify these. All right, so our n is equal to 30. Our they have a sample standard deviation equal to 29.5. We have a significance level equal to 0.01. And let me just make sure I get all the information here. All right. Now bringing over the chart here. So with the sample size of 30, that's going to be a degrees of freedom of 29. And this gives us the area to the right of the critical value. So since my significance level, once again, is 0.01, that means that I'm going to have in this area, I'm going to have 0.005. In this area, I'm going to have 0.005. And in this big area, I'm going to have 0.99. And if you weren't sure how to find that, you can just do 1 minus that, and that goes in the big area here. And then the remainder is divided by 2 and split into the two tails. So I could just do 1 minus 0.01, whatever that significance level is, which is 0.99. That goes into the main body, and then whatever the remainder is, which in this case is the significance level, divide that by 2, which is 0.005, and each one of those goes into my tail. All right, so going back and looking at my chart here, 0.005 to the right of the critical value, I'm going to go down to 29, and that value is 52.336. So this one here is 52.336. So that's my chi-square right. And the area to the right of chi-square left, critical value, is 0.99 plus 0.005, which is going to be 0.995. So that is this column here going down to degrees of freedom 29, because it's one less than our sample size, and that's 13.121. So this one is 13.121. All right, so the only thing really left for me to do, crunching numbers wise, is putting everything into this, figuring out what that test statistic is, seeing if it's in a tail, or seeing if it's in the main body. All right, so my chi-square test statistic is equal to, well, my n is 30 minus 1 times my sample standard deviation, which is 829.5 squared, all over my population standard deviation, which is my claimed value, 0.2 squared. So I can just put my calculator here. And so this is going to be 29 times 829.5 squared, enter, divided by 660.2 squared. And I'm going to get 45.78. So chi-square is equal to 45.78. And I can see that that's going to be somewhere between 13 and 52. So it's going to be right here. So that's going to be in the main body here. And so if it's in the main body using the critical value method, we fail to reject the null hypothesis. So here I'm going to fail to reject, just as if my p-value was greater than my significance level. It's the same finding there. So fail to reject means this could be good, which means that this is bad. That means that that's kind of bad. So if this could be good, that means that that's a possibility. That means that this is a possibility. It means we can't reject that. So what we're saying about this is that this value of 660.2 is in our realm of possibilities. So this standard deviation for girls is a possibility. It's in our. I mean, if we were doing a confidence interval, it would be one of the values that were in our confidence interval. So we can't dispute it. So we would say something like we can't reject it. It's a possibility. All right. I hope this helps. And if you have any questions, let me know. And have a great rest of your week. Thanks.